Privileged accounts are the powerful identities that keep enterprises running, but they can also cause the most damage when misused. In this section, we'll define who has privilege, where those accounts live, and why stronger controls are essential. We've already built the IAM foundation: identities, authentication, authorization, lifecycle, and governance. Now we'll narrow the focus to privileged accounts. These identities can change systems, data, and security controls, so understanding where they exist and what they control is essential. Before we examine attacks and PAM defenses, a privileged account is not defined only by the word admin. It is defined by what the account can actually do. If it can change configurations, access sensitive data, manage users, disable protections, or control infrastructure, it carries elevated risk. Once attackers compromise one of these accounts, they can move quickly from access to impact: data theft, disruption, persistence, or even full environment takeover. Privileged accounts fall into two broad families: human and non-human. Human privileged accounts belong to people, such as administrators, engineers, database administrators, and security operators. Their access is often interactive, tied to a named user, and protected with MFA or single sign-on. Non-human privileged accounts belong to technology: systems, services, applications, scripts, pipelines, and workloads. They usually authenticate with tokens, keys, or certificates, and may run continuously. Both can be extremely powerful. A strong PAM program adapts controls based on ownership, usage frequency, authentication method, and permission scope. Human privileged accounts are powerful because they map directly to the systems that keep the enterprise running. Domain administrators influence identity at scale, including authentication, directory services, policies, and trust relationships. Local administrators have deep control over specific servers, workstations, and endpoint data. System administrators often span operating systems, storage, infrastructure services, and major platforms. The mental model is scope plus impact. The broader the scope and the more critical the asset, the higher the risk. If an attacker captures one of these accounts, they may move from simple access to control to enterprise-wide change. Privileged access is not limited to domain admins or server admins. Many high-risk permissions sit inside business platforms. A database administrator may be able to read, change, export, or delete customer and financial records. A security administrator may tune detections, change alerting, or disable controls, which can hide an attack. An application administrator may control roles, integrations, workflows, and the rules that drive business processes. The key point is this: privilege is defined by impact, not by job title or operating system rights. If an account can affect critical data or decisions, treat it as privileged. Cloud and SaaS administrators are powerful because their authority crosses many boundaries. One account may manage identities, create cloud resources, change networks, assign roles, read storage, or modify encryption and security policies. In Microsoft 365, Entra ID, or similar tenants, a global admin can influence users, apps, access rules, and integrations. SaaS admins may control CRM, HR, finance, collaboration, or ticketing data. The risk is not one permission. It is the connected reach across regions, subscriptions, tenants, APIs, and services. That reach makes these accounts high-value targets and demands strong controls. For human users, the safest model is separation. Use a standard account for everyday work, such as email, browsing, collaboration, and business applications. That account should not have standing administrative power. When elevated access is needed, the user switches into a separate admin identity, ideally through a request, MFA, approval, and session logging. This creates a clean boundary between normal productivity and higher-risk administrative activity. Shared admin accounts break that boundary because actions cannot be tied to one person. If they still exist, control them through PAM. The goal is simple: limit privilege, reduce phishing impact, and make every privileged action accountable. Privilege also lives in accounts that no person signs into directly. Service accounts keep background processes, scheduled jobs, and infrastructure running. Application accounts let software connect to databases, APIs, directories, and other services. Because these accounts operate quietly and often use long-lived or embedded credentials, they are easy to overlook. If an attacker finds one, it can provide a stable, hard-to-detect path back into the environment. In modern environments, automation often holds the keys. Deployment pipelines, infrastructure as code, scheduled jobs, and maintenance scripts need credentials to act without human involvement. Those credentials may be API tokens, SSH keys, certificates, connection strings, encryption keys, or stored passwords. Because they connect into cloud platforms, SaaS apps, repositories, security tools, and infrastructure, one exposed secret can become a direct path to privileged access. During discovery, look in CI/CD systems, source code, configuration files, servers, cloud consoles, and secret stores, especially for hard-coded, shared, or never-expiring credentials. Cloud-native systems try to avoid long-lived passwords by giving the workload an identity at runtime. That workload might be a virtual machine, container, function, application, or service. The cloud identity system then issues temporary credentials or tokens. Those permissions determine what the workload can reach: storage, databases, secrets, queues, APIs, networks, and even management operations. This is safer than embedding static keys, but it is not automatically least privilege. If a workload identity is over-permissioned, compromised code can use it to escalate privilege, move laterally, or access sensitive data. Privilege is not just about what an account can do. It is also about how far that power reaches. A local administrator may control one laptop or server, so the blast radius is contained. A domain or tenant administrator can affect many users, policies, and connected applications. Platform-level access reaches cloud accounts, SaaS tools, virtualization layers, or security consoles. Enterprise-wide access is the highest concern because one credential can influence multiple regions, business units, or identity domains. When prioritizing controls, always ask, if this account is misused, how much of the organization can it change or disrupt? Blast radius is the difference between a bad day and an enterprise incident. If a local admin account is compromised, the attacker may control one workstation. If a domain admin or broad service account is compromised, that same attacker can reach servers, databases, file shares, cloud resources, and directory services. Scope changes everything: data exposure, outages, escalation, persistence, and audit findings. Least privilege is not just tidy access management. It is damage containment reinforced by segmentation, just-in-time elevation, and PAM controls. Protecting privileged access starts with knowing exactly what exists. Begin with discovery across directories, endpoints, databases, applications, cloud platforms, DevOps tools, and SaaS. Then classify each identity: human user, service account, application, automation job, API token, SSH key, secret, or workload identity. Ownership comes next because unmanaged accounts become orphaned risk. After that, assess risk using privilege level, access scope, credential age, usage pattern, authentication strength, and exposure. Prioritize the accounts that combine broad access with weak controls, shared use, unknown owners, or hard-coded credentials. Privileged access is bigger than administrator logins. It includes service accounts, secrets, keys, APIs, and workload identities. Real risk comes from what each identity can do, where it can reach, how exposed its credentials are, and its blast radius. Strong PAM starts with discovery, classification, ownership, and prioritization. Next, we'll see how attackers exploit that access.